Okay, now we'll start here defining vectors. What is the meaning of vector? A vector quantity. What is the meaning of a vector quantity? A vector quantity, what is the meaning of a vector quantity? A vector quantity is known to has a magnitude and direction. Something like what? Like a displacement, velocity, acceleration, force. When I say here, for example, I give my friend a push with 20 Newton to the left. So I can describe this quantity, which is the force, I can describe it by both magnitude and direction to the left. So this quantity is said to be a vector quantity. But if I describe, for example, the speed of the object or the number of pages, I cannot say that the number of pages is 50, for example, to the left or to the right. I cannot describe this quantity by both magnitude and direction. That's why it's called a scalar. So again, the difference between scalars and vectors is that vector quantity, any vector quantity has both magnitude and direction, while any scalar quantity has only magnitude and could only be described by a value or a number. Hello, okay, so this is the meaning of vector quantity, and here we will describe or we will represent the vector quantity by an arrow, and you can see here the arrow has a tip and tail. This is the tip and this is the tail. The length of the arrow shows you the magnitude of that vector. For example, here I have this arrow longer than this one. This means that the magnitude of that vector, suppose that this vector is A, for example, so I will just show here. Suppose that this is A and this is B. So this is a longer arrow. It means that it has a magnitude, say, for example, 2 Newton. This will be less than this one because it is shorter here. So I can say that this is 1 Newton, for example. And the tip of the arrow will show you the direction here. It is directed toward the east. And of course, the other one is directed to the west. So the tip of the arrow shows you the direction, and the length of the arrow shows you the magnitude of that vector. Now, if I continue here with an example, we need to know that if I add two vectors, I can add them in any order. Something like what? Vectors simply, as we said, they contain direction or they have direction. That's why I need to take care of the direction. Similar to what? Similar if I tell you, for example, that I need to add 5 plus -3. You cannot just tell me that I'm going to add them without taking care of the or considering the sign. You cannot say that this is equal to 8. So 5 plus -3 is not equal to 8, but I have to take care of the sign. So 5 plus -3 is 2. This is because of the sign. Similarly, people here, when we are dealing with the vectors, you need to take care of the direction. I can just switch position here. So I can say that I'm going to add -3 plus 5. It will give me 2. So I can change the order. Also here, if I'm adding vector A to vector B, I can switch their position or change the order. So I can just start by B and add to it A without any problem. So vectors can be added in any order. And when I subtract, it means that I add the opposite. I reverse the direction, then I add the opposite. Now I'm gonna go through the graphical method. Today we are gonna learn how to use graphs to add two vectors, and we are gonna check that by the algebraic method. So we know now that we can work out with vectors or add vectors both algebraically and graphically. The required one in your curriculum is adding two vectors graphically. What is the need of adding them algebraically? This will give you an idea about the precise answer. so you can check yourself and you can know exactly how the answer will be. For example, here we have, before I start adding two vectors graphically, I need to tell you that if the two vectors are in the same direction, as we agreed before, that vectors have directions, that's why I need to take care of that direction. So if the two vectors that you are adding are in the same direction, all you have to do is to add them normally. So 5 plus 8 will give you 13, and the resultant vector of the total vector will be in the direction of both of them. So 5 plus 8 to the right will give me 13 to the right. You can see clearly here that the arrow has been longer to show more magnitude or greater magnitude. Now, what if these two vectors are in opposite directions? They are parallel to each other, but they are in opposite directions. So I need to subtract them here. I will never add two vectors that are in opposite directions. You need to subtract them, and the resultant vector will be in the direction of the greater one. Similar to working with integers, no difference. Okay, this is the second rule. I got to know that two vectors in the same direction will be added and two vectors in opposite directions will be subtracted. What about if they are perpendicular to each other? Something like a vector. For example, I have here a vector to the south and another vector to the east. I know that the east and south are perpendicular. So at that time, I cannot add, I cannot subtract, but I have to use Pythagorean theorem in order to find the resultant. What is, suppose that this is, for example, 3 and this is 4. So all I have to do is to get the resultant vector by adding their squares under the radical. So it will be 3 squared plus 4 squared. Remember, Pythagoras states that c squared is equal to a squared plus b squared. So to get the resultant, I will square this under the radical. I will get 9 plus 16, which is radical 25. That gives you a 5. Remember that a vector quantity could be any of the quantities that I described before. If I say, for example, this is Newton and this is Newton, so my vector quantity here is the force. If I replace it by meter, quantity will be displacement. So 3 meter displacement to the right and another 4 meter displacement downward or southward. This means that I'm talking about displacement. If I change this to meter per second, at that time I'm talking about velocity, not speed. If I change it to meter per second square, it will be for acceleration. So the quantity that you are dealing with could be known just by checking the unit. Now we know now that two vectors could be added, will be added normally if they are in the same direction. If they are in opposite direction, I should subtract. If they are perpendicular, I will use Pythagoras in this way, adding the squares under the radical. This will give you directly the result. What about if the two vectors are none of the previous cases? By means, they are making just an angle between each other, but they are not in the same direction nor in any of the cases before. So suppose that I have here 4 meter in this direction and another 6 meters with an angle like 60 degrees. At that time, this doesn't match any of the previous cases. So this is our lesson today. We'll focus on it and we'll solve the problems from past papers related to two vectors that are including an angle other than 90 between them. At that time, we need to use the graphical method. What is the graphical method? The graphical method actually has 2 cases, the graphical method. I need to draw by using a scale these 2 vectors and add them by using that scale. So the graphical method could be any of 2. The parallelogram method, And the other method is the triangle method. What is the difference? We'll come to know now. The triangle method and the parallelogram method. And the most common one is the parallelogram in your problems. I will show you the difference. In order to use the triangle method, you need to connect the two vectors that you are dealing with in such a way that a tip is connected to a tail. For example, here I have here 4 or 2 meters in the east, 2 meters to the east. And I have here another vector that is 3 meters and making an angle 30 with the horizontal. Okay, this is 30 with the horizontal. Now, I cannot just add this to or complete the triangle here when they are in this way. Why? Because I need to connect them first, tip to tail, tip to tail. So the first vector will be drawn, and the second vector will be connected to it, but connected to the tail of the second should be connected to the tip of the first. In this way, the two white arrows represent the main, the two vectors that I am adding, and this one is representing the resultant or the sum of these two vectors. I know that you may not have gained the full knowledge, so I will remind you here by this one. Suppose that we are having an angle of theta between the two vectors, so the red one will be always the resultant vector or the sum or the total. Okay, so how I do that? I connected first the two vectors in such a way that tip is of the first is connected to tail of the second. Then the resultant vector will always close their way. I always imagine that they are running after each other, and the resultant is gonna block their way. They are running, and the resultant is gonna be connected from the tail of the first and the tip of the second in this way. Just notice the way and checking them algebraically. I will show you later how to check your resultant algebraically by using the cosine law. I know that cosine law was just introduced in your math course, so you already know about the cosine law. But before we check and apply or solve the problems together, I will introduce the parallelogram method. The parallelogram method. What is the main difference between the triangle method and the parallelogram method? Is that the two vectors here in the parallelogram method can be connected tail to tail, as you can see here. I don't have to connect or to move a vector parallel to itself in order to connect it tip to tail. So I have the two vectors here shown. I just complete the parallelogram or close the parallelogram that they form, and the diagonal of the parallelogram will show you the resultant. Again, the parallelogram method is the most common method because the two vectors are now connected in any way, not tip to tail, nothing. So if you see that the two vectors are connected tail to tail or tip to tail, you can just connect the parallel or complete the parallelogram like this and find the diagonal of that parallelogram. This diagonal is representing the resultant vector. How to check it? I can I show here the sign law, but I changed the sign. I will not tell you why I changed the sign into positive, because of some complicated steps in trigonometry. But all you have to know here is if you are using the parallelogram method and you have the theta, which is between the two, the angle between the two vectors, you need to put a positive sign in the law of cosine. Leave this now. This is only for checking, but let us go together and find how or understand how to use the vector or to use a scale to solve the problems related to vectors. I will go to 1 minute. Okay. One minute. I will show you here. You can see my screen. So now this is an example from your past papers. Let us read it, understand, and see how to apply a scale or use a scale to find the resultant vector. Here, figure 1.1 shows a river in which the velocity, this is the velocity of the flowing water, is 0.85 meter per second, parallel to the river bank. This is the river bank, and the water is flowing in this direction. So I'm talking here, I will check the unit. I'm talking about the vector quantity. Here is the velocity. So I'm talking about velocity. I noticed that from the unit. So the first vector is directed toward the east and has a magnitude of 0.85. Now, what about the other vector? You can clearly see the other vector is drawn and it has a magnitude of 1.2 meter per second and it has an angle of 45 with the horizontal. Now, I need to find out the result. Okay, now you will be having a space here and you will be asked to draw or use a scale to get the resultant vector of both vectors. Now, the first vector is 0.85 to the east. So what shall I do here? I'll just bring, I will draw on my space here the ruler. I will use a ruler, of course. You have to bring your geometry set with you. Now I will draw first the first vector. This is the first vector, but I need to, before I start drawing, I need to take a scale. How to take the scale or to choose your scale, you need to figure out or compare the two quantities that you have. I have 0.85 and I have 1.2. There is no common factor between them. So I chose to take this is very small quantity. If I draw with 0.85, not even 1 centimeter, I'll get a very wrong answer. So I need to make it reasonable. So I took that every 1 centimeter represents 0.1 meter per second. Why? Because in this case, I'll be able to make my drawing bigger. So 0.85 will be drawn, to make a cross product. So 0.85 over 0.1 will give you 8.5 centimeters. So the first vector that is to the right will be represented by 8.5 centimeters on my drawing. What about the 1.2? The 1.2 will be represented as 12 centimeters on my drawing. This is how to choose a scale. Now, let us see more examples later. We'll see more examples and we'll see how to choose a proper scale. Remember that the greater your drawing, by means the bigger the length, the less the error that you will get. By means, try to make your drawing bigger. Why? To avoid the errors. Okay, it will become more precise. Now I have drawn here, I need 8.5 centimeters to the right. So what shall I do? I will start here, bringing my ruler, and I will be measuring here the 8.5. Okay. I will start from the beginning of the line here. You put, okay. Now, I need 8.5 exactly. So I'll take this one and shorten it to 8.5. Okay. It's 8.5. The upper one is the inches. So remember 8.5 means here. I will shorten my, of course, this will be easier with real ruler. Okay. Now I have drawn now the first vector. Now I need to draw the other vector, which is 12 centimeter with an angle of 45 with the horizontal, as you know. Go back to the question. It was like this. If you look at the question, the first vector was making 45 degree with the horizontal. So I'll be back to my drawing here. I'll bring my protractor. Of course, you have to use here geometry set, otherwise you will get a wrong answer. So I'll just take my protractor down here. I need to measure. I'll put the middle of the protractor exactly at the end, as you can see here. And I will be measuring 45 in this direction. So 45 here. This is the 45 degree. Of course, you have to know when to choose the upper measurement and when to choose the lower one. It's an acute angle. So you measure the small by using the small angle here. It is 45 degree. I got now the direction. So I will take this out. Okay. I will start drawing 12 centimeter in this direction. So my arrow here. Okay. Now, let me ask you one question. I hope you are able to answer. Can you see here which method I prefer? It will be easier for me to use here. Which method? Is it the parallelogram method or the triangle method? Miss, I cannot answer your question unless I look at the arrows. Are they connected tip to tail or they are just connected tail to tail? So I take the parallelogram method. Anyone has an answer? Anyone has an answer? Okay. This is easier with the triangle method. I have here shown the angle and I have measured the first vector, but I still need to measure the second vector 12 centimeters. So what shall I do here? I will bring my ruler and measure 12 centimeters. One minute. Just that I need to adjust the ruler. Of course, we place it at the beginning here, the 0 with the 0. Okay. Now I will start measuring 12 centimeters. This is the 12. So this is the end of my vector. And now everything is clear if you just stick to the rules. Here I have drawn the first vector. Second vector also is drawn. So I have two vectors here. Two vectors connected tip to tail. I will take away my ruler now and draw the resultant vector. Okay. Do you have any question related to this part? Now we will be drawing the resultant vector. How? I will show the resultant vector by the red color. This is the resultant vector, sorry. Okay, this is the resultant vector, and you need to use the ruler to get it exactly. For example, here I will bring my ruler, measure the resultant vector, get it exactly, and remember to use the scale back to return this one to its actual value. Okay, of course, this will be much easier in by using a real ruler and a real protractor. Okay, so I got here around 8.5. This is the result. I got 8.5 or 9. Sorry, it's no, it's not precise. You take exactly. So it's about 8.5 or 9. Now I need to check myself again. Again, this is the angle between them. It was 45, and I connected them tip to tail. This one is the first vector. It is measuring 8.5, which represents 0.85 meter per second. The other one is 1.2 or 12, which represent 1.2 meter per second. Now I got the resultant like this. If I need to find out whether my reading is correct or not, I need to use the cosine law. The cosine law is just like this, as we agreed. It's like c squared equal a squared plus b squared minus 2ab cosine the angle between them. So c will be radical of all of this. So I will be squaring and you continue times the first vector times the second vector. You can use your calculator and cosine the angle between them, which is 45. Now use your calculator and check your answer. 0.85 squared plus 1.2 squared minus 2 times 0.85 times 1.2 times cosine 45. I got exactly, remember I got here a reading of 8.5, which represents 0.85 meter per second. Remember, when you get an answer, return it back to its original or actual one. I got here 8.5. So this means that the resultant is 0.85. This is the required type. When I checked this by using my calculator, I found out that the actual one is 0.848, which is so close to my answer. So my answer is correct. So this is what? This is the resultant vector. Please remember to use the cosine law if you are checking your answer, because you know that graphical method does not give a precise answer, but you have range of answers. So in order to be able to get or to check your results here, you need to use the cosine law. And now we will solve one more question. This is another question from the past papers. It's actually a part of another question of momentum, but at last you have two vectors. One of them is 3 kilogram meter per second. So the vector that I'm talking about here is the momentum. From where do you know? From the unit. The unit here is the unit of momentum. And we know that momentum is a vector quantity, has both magnitude and direction. So this is the first vector, and this is the second vector, and I need to get the resultant vector. Now I will show you by using, have a look to this. Now you can see here that I have two vectors and they are not connected tip to tail as the one before. So the easier method here is to complete the parallelogram, and find out the diagonal. The diagonal is going to be the resultant vector of these two. As we agreed before, I have to first to decide whether the parallelogram method is easier for me or the triangle method. And according to the question, I will decide. Here, I decided to take the parallelogram method. And before I start drawing anything, I need to choose a scale. And the scale, you have to choose the scale by comparing the given vectors here. I have 2.4, which is like 24, and this is a 3, like 30. So both are divisible by 3. So that's why I took, but I need, if I divide them both by 3, I will get very small values. That's why I divided by 3 and multiplied by 10. I took this as my scale. Why? To make my reading bigger. First of all, I've seen that both are divisible by 3, and they will get me a very small value. So that's why I multiplied by 10. Now, I got the scale that every 10 over 3 centimeter, which is like this, will give me 1 kilogram meter per second. So 2.4 kilogram meter per second will give me what? I make cross product, multiply this time this. So 2.4 times 10 to the power of 3, 10 divided by 3 gives you 8. Okay, and this, of course, will give you 10. Now, my length, the two lengths are very reasonable. So I will, inshallah, I will not get a wrong answer. So first of all, I need to draw here. The first vector is 2.4 here to the east. So I will start drawing here a vector to the east. Then I have to exactly measure it 8 centimeter. And now I will take it here to the edge of the line and start measuring it precisely. 8. Now it should be 8. Of course, you will erase. So I'll take it to the 8 and stop here. Okay, this is your first vector. I've drawn it 8 centimeter to the east. Now I need to measure 45 degree from here. Okay, I will take this out. And I bring my protractor. Place it here at the beginning of the line where the angle should exist. And I have to measure 45 degrees. Look here, should I take the upper reading or the lower reading? It's 45, so it's an acute angle. So I'll take the lower reading here, which is the 45. Okay. Now I have to draw again another vector. Now I got the direction. So I'll draw another vector in this direction with different color. Of course, you don't have colors, but I will show you by using colors here, show the difference between the two vectors. Now this is the second vector here. I need to take exactly measure 10 centimeter. So take it down. Now you can clearly see that this is longer one. So I'll shorten it to the 10. So what I will do here, I will erase the rest. Just erase it and make it only 10. This is the second vector. Now, how to complete the parallelogram? I need to place here the same one as here, and also here the same one as here. So I'll take the first measurement. I prefer to use a compass, but if you are not able to use the compass, you can also use a ruler, but make sure that the lines are parallel. By means, I will start here taking the reading of this first one. Then I will place it here. Bring it up to the second. I took the reading of the first vector. And I will take it here upward. I will go up, connect it to the end of the first vector, the second vector, I mean. Here, I will draw an arrow, an arc, okay? Draw an arc like this. Now, with the second, okay, and I've got the first vector, I need to take the second also measurement. I know that the compass may not be able to. Okay. Now, this is the maximum of my compass here, but of course your compass will be able to take another arc. I will take the reading of the second vector and I will copy it from the end of the first one, like this. So, as you can see, they shoot the two arcs. If you are able with your compass to open it till 10, which is possible, you will be able to get another arc, and the two arcs will meet in a point. And this is the parallelogram. Show the examiner that you are drawing a parallelogram, otherwise you will lose marks. You should show that you have closed or you have formed a parallelogram. Okay. Now I will complete the parallelogram. Now I completed my parallelogram here. Now the diagonal should represent the resultant vector. This is the diagonal. That is my resultant vector. Okay, now we usually draw two arrows on the resultant vector to show that this is the result. So I have got now the resultant vector. The last step is to read or to measure. Yeah, take the measurement by using a ruler and measure this resultant. Okay, make it precise by just adjusting the 0 with the 0. I got it around 16 and a half. I got it 16 and a half. Is this the actual momentum? Is this the actual resultant momentum? Of course not, because you need to figure out this value by using the scale. What are you going to do? You will be making cross product. So you will be dividing 16 divided by 10 over 3. It will give you 4.8 kilogram meter per second. Now, I need to check myself whether my reading is precise or not. Remember to use the cosine law, but here the angle between them is not given. So I will take the supplementary angle. At last, I don't want you to go to complicated methods, but you have to use this one with the positive sign, because the angle here is this one. The angle for the cosine law is this one, not the one given between them. So this is not 45. I will take the complement of the supplementary angle. And you can have a result equal to this one. This is the cosine law. I changed the positive sign into the negative sign into positive, because I don't have the angle and they are not connected to the tail, as I told you before. This is the cosine. I changed the sign. Cosine law, but I changed the sign. Now you will be having it like this. So what is A? A is the first vector. The first vector is 2.5, 2.4. I'll square it. And the second vector is 3. I square it. Then plus 2 times the first vector, the second vector, times cosine the given angle. Now, if you use the cosine here, use your calculator. Now I got an answer exactly equal to 4.99. So getting it 4.8 is very good. And the range, if you check the mark scheme, you will see that it is inside the range. So this is the method of how to add two vectors graphically and check them algebraically. And we have solved today 2 examples. And the last one that I want to show here is another example, but this time it will be homework. You need to try it yourself and check whether you got the explanation today or not. Okay, any question? Do you have any question? Okay, thank you. I hope you understood everything. Thank you, Sarah. Thank you very much. Okay, so I hope you understand everything. Please write it's March 21. Okay, so you can do your homework. Thank you very much. Bye-bye.